We're recording, so any misbehavior will be recorded. Oh God, that works so well. All right.
Wait, I'm using.
I'm using that. All right, so let's try this. Go ahead, put your face in there. Then I have to have you sign a release so I can post it up on the website. All right, give me two-digit numbers to multiply.
16 and 20.
16 and 20. Okay. 16 and 20. Give me something harder. Give me something without a zero at the end, because zero makes it easy.
14 and 13.
14 and 13. I'm going to write them down. Okay, I'm going to write them down. Now, I'm going to try and do this in my head. I haven't done this before, so. All right, 14 times 13. So, 10 times 10 is 100. 10 times 10 is 100. 4 times 3 is 12. Okay? And then 4 plus 3, 7. So 14 plus 12 plus 100. No, that's not right. 14 plus 12 plus.
I'll just do it for you.
I'm trying to sell this. And I can't.
182.
182. All right. I can't sell it by doing it in my head. I don't have enough practice. So we're going to do it on paper a long way. Who remembers this beautiful thing?
Yep.
The box method, or more accurately, the area model for polynomial multiplication. Yes? But we're not going to talk about polynomials right now. We're just going to talk numbers. If I wanted to multiply 14 times 13, I wanted to break it down into easier stuff. What would you suggest I break the 14 down into? Devin, give me something.
Break it down.
Break it down into the sum of two smaller numbers.
You can do 10 and 4.
10 and 4. That's what I chose, right? Because multiplying by 10 is easy, right? 10 and 4. Okay, Jesse, what would you break down the 13 into? 10 and 3. I like those numbers. All right? So then I multiply stuff together to find the area of each individual square, right? So 10 times 10. Go ahead and lay it on me, Nick. 100. 4 times 10. Jeff. 40. I'm practicing names while we learn. All right? 3 times 10. Ava. 30. Who said that? Brandon. Yeah, I know Brandon. Let me try somebody that I don't know as well. I don't know this young lady in the gray sweater as well, and I can't. And I'm sorry, Allie. Okay, Allie. What is the last one? What should I put in the last one? 12. Okay, good. All right. And then what do I do to find the product of 14 times 13? What's the area of this big box?
182.
It's the sum of all the smaller areas, right? 182. Okay? Now, that's what they did here at the beginning with 28 times 27. The same thing. So I want you guys to break that down using the area model. So go ahead. Good. All right. I saw a lot of numbers that I like a lot. So let's try this. Oh, look at that. Look at that. And then let's do there and there. And so what did we choose to break it down to? Well, they told us what to break it down into. 20 plus 8 times 20 plus 7. And then I get what? What did I get in this box, Andrew? 400? 20 times 8, Bailey.
160.
160.
160. And then, so not Allie, but right behind, is that Jasmine right behind Allie? Yes. All right, what'd you get for here? 20 times 7. 140? And then right next to Jasmine, that's Tabitha, yes? It's coming to me. All right, what's this one right here? 56. 56. And then to find the area of the total, I just add them all together. 160 plus 140, 300 plus 400, 700, 56. 756. There we go. Okay, now, if we can do that, why can't we do it when I have a variable? Well, we can, right? We can. Okay? Now, one thing that Mr. Erickson made sure to point out to me so that I could point out to you is do the variable first and then the number. So we read left to right and then up to down, right? Variable, then number. Variable, then number. Okay? If you do that, then you can just add this diagonal together. You see that? And it's kind of convenient here, but it's really convenient when we get further along in the lesson, okay? So let me take that off. So do we see how that works? So the product of these two binomials, why is it called a binomial? Because I got two terms, right? The x is a term and the 8 is a term. So that's a binomial, as is x and 7. That's a binomial. But when I multiply them together, I get what? I get, well, the sum of x squareds is x squared. The sum of 8x and 7x is positive 15, right? X. And then I got just 1 plus 56. Now, 56. 50. So, what kind of polynomial is this? Is this a binomial? There you go. Trinomial, right? Yeah. Bicycle, tricycle, binomial, trinomial, right? Right? Polynomial means many terms. Well, poly means many, right? Not a specific number. Poly. All right. Get past that. Okay, so now, hi Leah. We're filming for you.
Oh.
All right, yay. All right, so now, here's what we're going to do. We're going to use the same method to multiply these two guys. What's unique about these two guys? Taylor, what's unique about these two guys? They're trinomials. Have we multiplied trinomials before?
Yes, we have last year.
Did we?
No.
In geometry?
Yeah.
Algebra
Algebra 1, I mean.
Okay. Now, remember what I said when I'm multiplying binomials. I want to do the variable first, number second, right? But I got two things with variables.
What do you do?
Which one do you think I put first? What do you think, Leah? Oh, you mean you don't want to answer my question without a packet? Whatever. More. There you go. You're welcome. So, what do you think we should do? What should I put first? The x term, or the x squared term? X squared term. I like that idea, right? Same thing over here. Put the x squared term before the x term. So, I want to see you guys do that. So go ahead and do that using the area model. They call it the tabular method, but I'm calling it the area model because reasons. I'm going to do that. There.
Is it a 3x3 or 2x3?
How many terms? Is this 3? That's trinomial, right? What's this? Trinomial, right? So 3 by 3. Yes. Yes, very good. 4. So, real quick, let's do this real quick. I want Not that I think you guys don't know this, but I want to make sure you understand it clearly. X squared times x squared.
Four.
It equals x to the fourth, right? Equals x to the fourth. Why? Why? If I multiply these two, I multiply the exponents. So then x cubed times x cubed is x to the ninth. You add them, right? You add them. Why do you add the exponents? Because it works. Because reasons, right? Because reasons. Here's why we do it, okay? Let's think about what x squared is. X squared is x times x, right? And I'm multiplying it by x squared, which is also x times x. So then I'm multiplying x times x times x times x. X to the fourth, right? How about this? Listen up. This is important. Maybe not now, but later. What about x squared squared? What is that?
X4.
It is x squared times x squared, which gets me back to x to the fourth. But what about x cubed cubed?
X9.
X9. Why?
Times it.
Because this is x cubed times x cubed times x cubed, right? Which equals what? Everywhere, isn't it? X times 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 x. I got 9 of those, right? Hence x to the 9th. All right? So, if you get stuck, and the reason I'm talking about this isn't in the lesson, right? This is one of Mr. Cook's tangents. Sort of like yesterday we had an unfortunate tangent, right, Ethan? So why do I share this tangent with you, though?
You're a good teacher.
Well, thank you. You say that to all your teachers, though, don't you?
No, I hate most of my teachers.
Oh, I'm sorry to hear that, but thank you. So the reason I tell you this is if you ever get stuck, who's ever gotten stuck saying, oh, what do I do? Do I add or do I multiply? Right? We do that all the time, right? Break it down to your definitions. You remember that part of your math class that you always ignore because I don't care about definitions? Kind of the most important thing here. You need to know what x squared means. You guys know what multiplying means, right? Do you know what x squared means? Well, of course you do.
It means the number, something that equals x squared.
Well, it means x times itself, right?
X times itself.
So if I do that, if I break it down to my definitions, I should be able to answer my own question and come out with the right answer. And not only that, but understand why. So, anyhow. All right, so back to my tabular method. Camden, what did you put on the top of your Punnett square? What did you put up here? Oh, hold on, keep it down so I can hear. Sorry, bud. X squared, 3x, and lastly, 1. All positive? All right, cool. You ready to join? Are you got your sea legs? Right on the side, what'd you put? Oh, what did I forget here? All right, x squared minus 5x. What did she remember?
Negative.
The negative, very important, right? And lastly, Leah, due. It's Italian for 2. Okay. Jordan, top left box. Thank you. Oh, thank you. I was about to okay. X to the 4th. Very good. All right. No.
Ready for the slide?
There we go. All right. Next box over. I'm working on names. Next to Brandon. Not Brandon, but next to Brandon. Yes. What's your name again? Caleb. Thank you. Next box over. What'd you get? 3x cubed. I'll buy that for $1. All right. Enough sarcastic clapping, please.
That wasn't sarcastic.
That was sincere? I apologize. All right. Top right. Top right. Bailey.
X squared.
X squared.
Oh, you wrote it.
All right. Middle box left. Taylor. Middle box left.
-5x cubed.
Aha. Thank you. Okay.
And then
Somebody else. Alice is spotting the Brady Bunch here.
Jesse Johnson.
Anybody seen the Brady Bunch before?
Oh yeah.
Alice is always here, right?
Yeah.
All right. Andrew, what'd you put in that box?
That'd be -15x squared.
There we go. -15x squared. And then on the middle right, Jeff, middle right. Very good. Thank you very much. All right, Jeff. All right. Bottom left. Devin. 2x squared. Ethan, bottom center.
6x.
6x.
Yeah.
Jordan, bottom right. 3.
Yes.
All right, now, did I say 3? Did I write down 3 when he said 2?
I was tricking you.
You tricked me. You did trick me. All right. Now, did we write our... I did it again. For the love of Mike. What did I write?
2.
Thank you.
There you go.
All right. Now, did I write my polynomials in the right order here? And right here. So what I can do then is I can go here. How many x's to the 4th do I have? X to the 4th. I don't need to write the 1, do I? How about here? How many x cubes? -2x cubed. And then the center. How many there?
-12.
1, okay, 15, 14, 13, -12. How about here? Right there. Is that better that I don't do that all the way through?
No X's.
6 minus 5
Oh.
X.
plus x plus 3. I meant to do that one. That was intense. That's a little math teacher humor right there. That's funny right there, I'll tell you. I don't care who you are. That's funny right there. I didn't try and do that one. 2. Got 3 on the brain. So, x to the 4th minus 2x cubed minus 12x squared plus x plus 2. All right? Caleb? Am I right?
Yes, you are.
Jeff, am I right?
Yeah.
All right. We done with sidebar?
Yes.
All right, cool. Now, let's go down and do the same thing, except with a trinomial and a binomial. So what's the size of my box?
5 means 3 by 2.
3 by 2.
Or 2 by 3 or 3 by 4 or 5 by 8.
No, not 4 by 8. 3 by 2. Or you could do 2 by 3. Either or.
That's how you're feeling.
Depends how you're feeling.
I'm good 2 by 3. I just created it.
Yeah, what do we get? When do we get out? All right, so we're done here. I want an answer for this on Monday, but if you choose to work ahead,
Wait, what answer do you need?
the problem, The one that we're doing just
I got the
now.
blacks, but I'm not sure how to put in an answer.
All right. Well, then stop where you're at then. But for the problem set, this is going to be due on Wednesday next week. Problems 1, 2, and 3. All of them. All of them. Thank you, Jordan. Josh. Jordan. Man. Damn. All right. You don't want to be on TV, Nick?